Good morning, students. Today we are going to read the second lecture of periodic table, and that is metals and non-metals. So this is again a technical topic. Some more concepts, some more ideas will be involved. So concentrate yourself. We are going to read now. 92 elements are found naturally on Earth. So this is one important point that you have to remember. Most can be sorted into two sets, the metals and the non-metals. Most of the elements are metals. There are about 20 non-metals. So it means almost 72 are metals and almost 20 are non-metals. A few elements like silicon are called semi-metals or metalloids. So this is a very important short question that almost come of 2 or 1 mark in the paper. Give one example of the element that is a semi-metal or metalloid. So silicon is the example, germanium is an other example. So metals, concentrate yourself. Over 3/4 of the elements are metals. Almost 70 elements are metals. And physical properties of metals are, so these are some properties which normally come in the paper. You have to remember them, you have to learn them. So look now, metals are good conductors of electricity. So electricity passes through easily through metals. So this is one property, that is metals are good conductors of electricity. Metals are good conductors of heat. So heat also passes through the metals easily. These are shiny. So these are shiny, not dull. They have shiny surfaces. Next is metals. These are magnetic metals, iron, cobalt, and nickel. So they have the magnetic properties. Metals are sonorous, rings when struck. So when we struck at the metal, it rings. Next is metals are ductile. Ductile means metals can be drawn out into wires. Next is metals are malleable. That is, metals can be hammered into shapes without cracking. So without cracking, metals can be reshaped into sheets or into the shapes, different shapes. So next point is metals having high melting point, and the last one is metals are dense because the molecules, the atoms are very close to each other. So that's why they are dense. Some exceptions are there. So this is another very important question that again come in the paper frequently. Some exceptions are there in the metals. So not all metals have these properties. For example, alkali metals, that is lithium, sodium, potassium, are soft metals. They have low densities and have low melting points. These are soft metals, even so soft that we can cut them with a knife. So these are so soft metals. Mercury also has a low melting point for a metal. So these are some exceptions in the metals. Chemical properties of the metals. The metal oxide made are solid. For example, Mg plus O2 forms MgO, that forms MgO. So metal oxides are made, are solids. If metal oxide dissolve in water, it makes an alkaline solution. For example, Na2O, when it is dissolved in water, it forms an alkaline solution, that is NaOH. Most metal oxides are basic. Okay, some metal oxides do not dissolve in water. So this is another short question that frequently come in the paper, because we have learned earlier that metal oxides dissolve in water, but some metal oxides do not dissolve in water. For example, iron oxide is insoluble. So these are alkalis. So alkalis are the metal oxides which dissolve in water, and the metal oxides which do not dissolve in water are not alkalis, they are called bases. So iron oxide and copper oxide are two important examples. Next, we are going to read non-metals. Physical properties of the non-metals are, so these are almost these reverse properties of the metals. Non-metals are poor conductor of the electricity. So electricity is not easily flow through the non-metals. They are poor conductors of heat. So heat does not pass easily through the non-metals. They are having dull surfaces, they are brittle if solid, and they are having low melting point. But at the same time, some exceptions are there. So exceptions is a very important question that you will see in the paper, and students can write answer on the properties of the metals and not metals easily, but they normally feel difficulty in writing the exception. Either it may be from metals or non-metals. So the metals which are having low melting point, or the metals which are in liquid form. At the same time, in non-metals also some exceptions are there. So look now, carbon in the form of the graphite is good conductor of electricity. Carbon in the form of diamond has very high melting point. So these are some exceptions. Chemical properties of non-metals. When a non-metal burn, their oxides are often gases. So example is here, carbon plus O2 forms carbon dioxide. So when non-metal burn, their oxides are often gases. So this is first chemical property. Second, most non-metals oxides dissolve in water to form acids. For example, CO2 plus H2O forms H2CO3. Most non-metal oxides are acidic. One exception is in the oxide is of hydrogen. Okay, metals, non-metals, and the periodic table. The periodic table has 8 groups. Group 1 and 2 are all metals, whereas group 7 and 0 are non-metals. However, the elements in the middle groups start with non-metals at the top but finish with the metals at the bottom. This is very important point. The elements in the middle groups start with the non-metals at the top, and gradually if we move from top to bottom, so we finish with the bottom at the metals, starting with non-metals at the top and bottom is non-metals, as metals. For example, here is we have taken one group, so that is group 4. If we move from top to bottom, the top is non-metals. In the middle are semi-metals or metalloids. So silicon and germanium are two examples. They are on the borderline between metals and non-metals. So these are on the borderline. And as we move further downwards, there will be metals. So if we move from top to bottom, it will start from non-metals, then semi-metals, and then metals. So from non-metals to metals. Silicon is the most well-known semi-metals. For example, it is shiny like a metal, but brittle like a non-metal. So this is the explanation why silicon is called a semi-metal. Tin oxide reacts like a metal oxide, but also react like a non-metal oxide. It is an amphoteric oxide, behave like an acid and a base. So this is another very important example. Normally an example is required from you people of amphoteric oxides. So amphoteric oxides are the oxides which behave like an acid and a base. And tin oxide is the example. This shows that science is not always black and white. Black and white means we cannot see these are metals and these are non-metals. So some of the elements are there which behave like metals as well as non-metals. So these are called metallites or semi-metals. The semi-metals are the gray area. However, we can draw an imaginary line in the periodic table. So this is very important point which you have to learn and remember. You can think of the line as the staircase. Below stairs are find metals. Above stairs you can find non-metals. So look now. Here is the staircase that we start from boron and like this. So here is the staircase. So look now. The below are metals. So these are blue portion is called metals. These yellow around the staircase are called semi-metals or metalloids, and the above portion of the staircase is called non-metals. So blue case is metals, yellow elements are called non-metals, and orange portion is called non-metals. So this is imaginary staircase which you can draw in the periodic table. That will be easy for you to remember. So this was the lecture, students. Read this lecture again, understand it, learn it, and make your notes. Thank you so much.